Hi, today I'm going to talk about working with multiple endpoints in NL Mixer, just slightly modified to work with this course. First off, we modify it so these runs are cached, so you don't have to wait for the run to complete. We'll start by evaluating this code, and then we'll talk a little bit about pharmacometric multiple endpoint models. So first thing we do is load NL Mixer, ggplot2, and then we clean any possible cache of models, except for the ones we just cached above, just to make sure things interact well. And we're looking at Warfarin, which is a joint PK/PD model, which is a classic example that was provided by Tumo and Nick. What we do here first, we look at this model. It consists of a turnover piece, a Ka, CLV, and it also has a proportional and additive error for the PK piece, as well as an indirect response model with Emax, EC50, Kout, and E0, with between subject variabilities, which again are modeled by with this tilde. So you have A to TR, Ka, CL, and V, Emax, EC50, Kout, and E0. Then we have this PD additive error. Inside the model, we set up the KTR to be log normally distributed on the between subject variabilities, as well as Ka, Cl, V. And for the Emax, it's going to be between 0 and 1. So it's xbit, which is basically a way of turning a logit value, which is up here, which is 0.8, to a value between 0 and 1. So this is just very easy to put in. So xbit, T Emax, which is our typical Emax, and our A to Emax. Then we have our EC50, our Kout, E0, DCP, and PD. And then here we have effect 0 is our E0 component. We have our Kn, which is our KE0 times Kout. Then we have this transfer component into the gut. And then from there, it goes in from the gut to the central compartment. And from the central compartment, we have this PD effect right here, which is based on this concentration that's described here in our effect compartment. Then we have our CP, and our CP, this is where we specify the model. Our CP is modeled by proportional and additive error. And again, these are actually on standard deviation scale. So this would be standard deviation, this would be a standard deviation. And effect would be the additive effect with this PD additive error. So all you do to do multiple endpoints is have this tilde in there. But there are actually some things that you have to think about in this. So this model by will give you a way to look at it. The first thing I would do is I would use NL Mixer to parse the model. And the way you do that is first by evaluating the model. You can see I forgot to evaluate the model up here. So first I evaluate the model. Then in NL Mixer, I use NL Mixer to parse the model, and it'll give me the information that NL Mixer uses to run the model. It gives you, this is an ODE-based model. These are initial estimates, and this is the omega initial estimates, as well as this piece right here, which has multiple endpoints. It's a little bit more difficult to read on this particular screen, but it tells you the variable. So this in case it's CP and effect, and then the compartment specifications. You can call the compartment in NL Mixer either CP or effect, or compartment number 5 or 4. We'll talk a little bit about how to change this just really quickly. So we have the CP, and then this is DVID is equal to CP or 1. That's what, in case you use the DVID specification, or the effect is DVID effect or DVID is equal to 2. So these DVIDs and these compartments are melded into one place eventually, but they are both can be used to model the data. This also gives you the mu referenced variables. Mu referencing is currently required for NL Mixer, but it won't be required for NL Mixer 2. We've redone the parsing and allowed non-mu referenced models in SAEM. Mu referencing is basically what you see in this model. You take your typical value and you take and plus it to your eta value here. Of course, if you just want to look at the multiple endpoint and what you need in your data, you can just access that by the $ multiple endpoint. handle that allows you to see what's going on in this particular data set. You can use, again, as we were discussed, you can use the names directly. But if you wanted to change something, like you wanted to, instead of having CP, you wanted to call it central, you could do that by adding this conditional statement, this up and down bracket where you put conditioned on central. So when you do that, let's just do that really quickly. We have this new model, Emacs2. And when we look at this, and we're just looking at a multiple endpoint piece, you can see instead of the CP, the compartment is center instead of CP. If you wanted to, you can change it so that DVID or compartment is used. So as I said before, it combines DVIDs. There's an option here, our RxODE combine DVID or not to combine it, and it allows you to change that. We're not really going to do much with that, but it is available. So as we do the summary of this particular data set, we see a little bit about it. The thing I like to keep in mind here is this DVID is parameterized in terms of CP and PCA. So just based on what we discussed here, we need to change this CP to an effect to CP, which is exactly the same. CP is what we're modeling, and then the effect we want to rename to PCA. So we have this little conditioned on PCA here. So when we do that, we evaluate the model. And then once we evaluate the model, we run the model. Now I'm using markdown in visual mode. It's similar in just source mode, but when you use markdown in general, you get something slightly different than what you get if you use the console version of Elixir. In this case, this shows that all the information was loaded from a model that was already run, but you can go through and look at the pieces of the Elixir fit. It tells you what it is and where to find it. So in this case, it's fit TOS $objective DF, tells you what's there. Then it tells you the timing of what particular pieces were there. And since this is something that is in RStudio, you can see these easily. You can go through and see more pieces to it. You can scroll to different parts of the estimation, since there's a lot of parameters that are estimated here, and see what the values are. And then you have an omega piece here, and this omega shows you the omega estimates. And then it has this correlation matrix, omega R, the shrinkage calculation, and all the information from the shrinkage, as well as any nodes in the fit. In this case, it tells you the covariance matrix type, and then the fit data itself. All Elixir's objects are actually data sets, so you could use it directly in something like ggplot or lattice or even base R graphics if you wish. Just as a note, if you decide to print it in just the console, it looks similar, but it's more of a console type of output here. So it has the same pieces. It tells you the objective functions, the times, tells you parameter estimates, and basically what they are estimated to, their standard error, their back transform values. So for example, with this TE max, it's going to be based on the 0 to 1 scale because we use that logit transform. And if with the TR, it goes back to the untransformed scale, not the log scale, and it gives you confidence bands based on that. And in this case, the CV percentages are listed for all the log normal values, and for the standard deviation value, that would be this one right here because it's not log transformed. It also gives you the shrinkage values for each of the ADAs, as well as any type of correlations that are strong. And it also tells you a little bit about the data set. Okay. Going back to the markdown layout, one of the things that you can do with these is you can print the diagnostics. You can also do a VPC. So Elixir provides a VPC function. In Elixir 2, it's VPC plot. In this case, it's just borrowing the VPC package from Ron Kaiser. And what you do is you show your observations. You want your Y scale to be free. And then we basically have this regular VPC. In the case of prediction corrected VPC, which is something that people often want to look at as well, all you do is use pred core equal to true, and LMixer will take care of adding the necessary pieces to the simulation to be able to do that as well. So if you do those two pieces, you'll get a VPC. This will take a little bit more time because the models themselves are cached, but the plots are not. You see here, all the plots that we have in NLMixer. It tells you all the warnings from the plots first. The next one is the trace plots. Sometimes with lots of plots, like in this case, in the markdown view, it's easier to show in a window. So if we open it in the window, we can see each of the plots here. So far, it seems to be reasonable. If you go towards the end, you'll see the VPC plot. And it does it by endpoint, so you can see different endpoint, and they'll also have individual plots by endpoint. You can also do the same sort of estimation with FOCEI and get the same diagnostics. Let's put this up here so you can see the print a little bit better first. So you can see the fit itself. When you look at the objective function, it's similar, and you can also see the plots here. Since we're more interested in the VPCs right now, we've already seen, you can take my word for it and look at it yourself, but you can see the VPCs here are also reasonable, and they also show pretty much a good model. So with that, thank you for taking some time. Some key points to remember is in NLMixer, if you want to have multiple endpoint model, you simply use two different model by expressions in your model itself. If you want to change the compartment specification, you can use the upward bracket and then tell the compartment specification you want. You can use either DVID or compartment as the way to specify which compartment or which types of endpoints you're looking at. And thank you for your time. I look forward for any questions you have.